Hi, this IB Physics Past Paper MCQ is about nuclear fission reaction. You know that it is a process in which the one heavy unstable nuclide, when it absorbs a neutron, it splits into the two lighter nuclide, which are relatively more stable. But I will give you the explanation of this. And in fact, this question is addressing about the binding energy per nucleon and the binding energy of these fragments and that unstable nuclide. So I will explain you not only theoretically but also from the graph. So let us see. So according to this question, this is that neutron when it hits the nuclide X, it splits into the relatively smaller in size, these two nuclides, whereas the two neutrons are emitted. Now, in the question, in a real question, it is just symbolically like these letters are assigned, but in reality we have a one prominent example of nuclear fission reaction of uranium. I want to mention you that reaction, and that is when a neutron collides with a uranium 92 235, it splits into the two fragments, which the one is xenon, that is 144 and 54, and the other one is a strontium, that is 38 and 90, plus the two neutrons are released, just like you see in this reaction. And don't forget to write the energy is also released during this reaction. So energy is released. Now, in our question we have to examine, we have to see that binding energy per nucleon of y, okay, which is the resultant, right, divided by the binding energy per nucleon of x, which is a parent element. So we have to find, is it greater than 1 or the less than 1. And second point is, we have to see if we add the binding energies of y plus the binding energy of the z, and we divide it with the binding energy of x, is this greater than 1 or less than 1? Let us see. Now, first of all, I will explain you that why the y and z are relatively more stable. The reason is that the reason is they are smaller in size. So if they are smaller in size, then what does it mean? It means that within those nucleides of Y and Z, the strong nuclear force, the force which is responsible to bind the protons and neutrons that overcome the repulsion between the same charges, same protons, this strong nuclear force comparably more dominant, more powerful than in the X. So that's why we should say that the Y and Z are more stable. Okay, and I will show you exactly this thing. Then X, I will show you exactly this thing from the binding energy per nucleon graph, which is very important because binding energy per nucleon is a factor, a decisive factor, which determines the stability of nuclide. It is not a binding energy, it's binding energy per nucleon. So if we see that this, I'm going to draw this roughly, this graph is something like this, right? So in this binding energy per nucleon graph, the top element that is a most stable is always an iron, right? But we are right now talking about the general. So let's say this is a X, okay, because you know that it has a largest nucleon number because it is converting into the Y and Z, it is producing. So if this is a X, then the Y and Z must have a less nucleon number. So dear students, you can assume, like for example, this is Y and this is Z, okay, like they should be close to each other, so obviously they will have the less nucleon number, right? So on this basis, don't you think that the binding energy of the Y is obviously per nucleon, I'm saying per nucleon for Y is obviously more than the binding energy per nucleon for X, what we see here. is exactly that thing. So if the binding energy of the Y is more, then it means that it should be 1 greater than 1 because it is more. Now, let's come to the second part. We know that the energy is released, and that is the energy which is released. So, how that energy is released? That energy is always released whenever this nuclear fission reaction takes place. Certain amount of mass of the X will be lost, and that will convert into the equivalent amount of energy which is released during the reaction. It means that the mass of X is more than the combined mass of Y and Z. So remember here, I'm talking about the nuclear mass of X is more than the sum of nuclear mass of Y and Z, because the difference of that mass is converted into the energy. So which means that the binding energy of X, because it's a heavy element, it's more than the sum of the binding energy of Y plus the binding energy of Z. It means that if we take the ratio, so that ratio should be more than 1. My mistake, less than 1, obviously, because it is more. So option C is the right answer for this MCQ.